Hey everyone, so welcome to this new video. This video we are going to talk about Java 21, Java version 21 features. Java 21 is the recent release by Oracle. It's a long-term support. Java has been releasing new version of Java every 6 months, and every 3 years they are releasing a version which they are going to support in longer run. All other versions are considered not to be supported in longer run. So it is important to see what features they have released in the Java 21 and how they are going to help us in better programming. So this short video, we are going to just get a glimpse of all those features that it has released. So let's get started. Release pattern: every 6 months, as I told, they are releasing, and every year the month of release is September and March and September, you can say. So the release comes in 3 categories, next you see they are releasing features under 4 categories, not 3 but 4 categories. Main features: some are preview features which is not to be used in production. They are just preview for the user feedback. If everything fine, they will move it to the main. The next category is the incubating, and the last one is the deprecation and removal. So if APIs or any feature is not being used, they are going to remove that. They are deprecating that one, and with every release they are announcing this one. Incubation means they are considering to add a new feature, but that is in very initial stage. When it passes that incubation period, it goes into the preview phase. When preview phase is passed, user feedback is fine and nothing is breaking, everyone is happy with that one, then finally it goes into the main feature list. When any feature is in the main release, it is good to use in the production. So let's see in Java 21 what we have in all these categories. So in summary, under main features, we are going to get the sequenced collection, generational ZGC, which is related to garbage collection, record patterns, matching pattern for switch, virtual threads, key encapsulation mechanism API. These are the main features that we are going to get. So let's go ahead a bit in detail and see what these are. So to get the official details, not any other internet website that they have published the summary only, but official website to see in detail official documentation, this is the website that you should go and check out that for every release. As of now, it is JDK 21, so you can see all the features that they have mentioned. So string template, sequence collection. So I have opened the main features in new tabs. So let's go ahead and see one by one. So first one is the sequenced collection. So what is this one? Introducing new interfaces to represent collections with a defined encounter order. Sequence, as its name suggests, it is going to be relating to something, sequences like first and last, second last sort of thing. Okay, so you can go read out more about this one and what is the motivation about this one. Java collection framework lacks a collection type that represents a sequence of elements with a defined encounter order. It also lacks a uniform set of operations that apply across such collections. These gaps have been a repeated source of problems and complaints. Let's see an example of this one. Okay, so see, when we talk about list, first element, how we get it, list.get0. Last element, how we get it, this is how we get it, right? List.get list.size -1. When we talk about deck, this is how we get first, get last. When we talk about sorted set, this is how we are getting the first and last element. When we talk about the linked hash set, we can get every next element using this one, but there is no way we can get the last element. You can see some of these are unnecessarily cumbersome, such as getting the last element of a list. Some are not even possible without heroics. The only way to get the last element of a linked hash set is to iterate the entire set. You see the problems with this one. So this sequenced collection is going to help us to streamline these sequencing and ordering. Let's see. You can see more examples around this one, and I am going bit down to see the how it is going to help in sequenced collection, how it is going to be there. So you see, this is the interface that is going to come. Sequenced collection extends collection, and these are the methods: sequenced collection reverse order, add first, add last, get first, get last, remove first, remove last, right? Obviously adding first last, getting first last, and removing first last. So there is a proper ordering, and any point of time we can reverse it, we can reverse that also. Obviously you can see when this sequenced collection you are going to use, it is going to give the uniformity across collections that we have, right? So this is all about this one. Further you can see the implementation, execution of this one, whatever documentation is there, they have put a lot of details around this, but in summary you get the gist what is this all about and what it is going to add that, right? So you see the architecture where they are going to fit this sequenced collection set. Sequenced collection is there, sequenced set is there, this is how it is going to be fit. Sequenced set is going to be sorted set, navigable, and linked hash set. On the map side we are going to have a sequenced map on this one, so a lot of uniformity is going to come here. So yeah, that's all about this sequenced collection. You can obviously go ahead and read more about this one. So next let's move to the generational ZGC. It is about garbage collection algorithms, how whenever any object is available for the garbage collection, how this algorithms run. So let's see the detail about this one. It is going to improve the application performance by extending the ZGC, Z garbage collector, to maintain separate generation for young and old objects. This will allow ZGC to collect young objects which tend to die young more frequently. What is the goal of this generational ZGC? Lower risk of allocation stalls, lower required heap memory overhead, lower garbage collection CPU overhead. These benefits should come without significant throughput reduction compared to the non-generational ZGC. The essential properties of non-generational ZGC should be preserved. Pause time should not exceed 1 millisecond. Heap sizes from a few hundred megabytes up to many terabytes should be supported or some. And minimal manual configuration should be needed. An example of the last point, there should be no need to manually configure the size of the generations, the number of the threads used by the garbage collector, or for how long objects should reside in the young generation. Okay, so it is not a goal of to perform reference processing in the young generation. Next you can see the motivation of why it is going to be improved. What is the main problems with the ZGC, and what is the inspiration behind this feature? You can read more about this one. Okay, so if I come a bit more about this one, what is this enabling generational ZGC? As of now, how we can enable it, because if anything new coming up, that succession should be smooth, right? So enable it, this is the command that we can use it to enable generational ZGC. On the design part we can talk more about, but this design one is going to take more time, because garbage collection we should give it a dedicated time to understand. So I'll create separate video around the ZGC in itself, and then we'll understand more about the generational ZGC sometime later. Okay, so let's pause it for now. If you want it, you have the link, direct link, you can go ahead and read more about it immediately. Moving to the next one, we have record patterns. So what is this? It is going to enhance the Java programming language with record patterns to deconstruct record values. Record patterns and type patterns can be nested to enable a powerful declarative and composable form of data navigation and processing. So let's see the example. Quickly come to the example what we have. Prior to Java 16 we had something like this. When we are typecasting something, so we first check the instance of, even if it is an instance of it, is still we needed to typecast it, right? But as of Java 16, what is, we did not need this line, this explicit typecasting. We could use this right away, right? So it can be enhanced more. So let's see what is there in Java 21. So this example, Java 16, you see this record is there, point int x int y. We can create the record this way, right? Static void print sum, if I have to do this one, so object instance of point p dot x p dot y, and this still we have to write these lines. So see how this can be improved. Line of codes can be reduced with this one. See, static void print sum object v, object instance of point int x int y, you write it here and directly use it at this point of here. So this is what we are going to get with the record patterns, right? So this is about the reduction in number of line and making our code more readable. So it is going to help there. Next is the pattern matching for switch. Let's see. It is again the readability and reducing the verbosity in the code. Goal: expand the expressiveness and applicability of the switch expression, allow the historical null hostility. Let's see the example. Example will make it more clear. So earlier, as we saw the record patterns, you see the example of this one, Java 16, right? Prior to Java 21, what we had, how we did this one. Let's see, we have a method formatter which is taking an argument object. We have formatted unknown, and it is just checking what is this input coming of instance of integer, instance of long, double. It is, and then formatted is going to be in that way. It is going to format that in whatever it is that for like whatever integer, long, or it is going to be there, it is going to be formatted in that way. So prior to Java 21, this is, if we needed to do this functionality, we had to do this line of code. Okay, so as of Java 21, see how we can be done. Formatted pattern switch. So object, we did it. Switch object integerize string dot format. So as part of returning this one, it can return it directly from here, right? So you see how many lines we reduced this one, and it is more readable now. Okay, so that's all about this pattern in switch expression, right? So we can it can help us a lot in putting more line of code in and making it more readable. Moving to the next one that we have, virtual threads. This is very interesting. Introduce virtual threads to the Java platform. Virtual threads are lightweight threads that dramatically reduces the effort of writing, maintaining, and observing high throughput concurrent applications. What is the history of the virtual threads? Virtual threads were proposed as a preview feature and delivered in JDK 19 as a preview. To allow time for feedback and to get more experience, they were proposed as a preview feature again by this JEP means Java Enhancement Proposal. This is how it new features has proposed, JDK 21. This ZEP proposes to finalize virtual threads in JDK 21 with the following changes from JDK 20. Virtual threads now always support thread local variables. It is no longer possible as it was in the preview releases. Next feature is virtual threads created directly with the thread.builder API as opposed to those created through executors.new virtual thread task executor are now also by default monitored throughout their lifetime and observable via the new thread dump described in the observing virtual thread section. What is the goal of this virtual threads? Enable server application written in the simple thread per request size style to scale with near optimal hardware utilization. Enable existing code that uses the java.lang.thread API to adopt virtual threads with minimal change. Enable easy troubleshooting, debugging, and profiling of virtual threads with existing JDK tools. What is not the goal of virtual threads? You can read more about this one. What is the motivation? There is a lot to read about the virtual threads. Means earlier, let's go a bit more about this one. There is a lot about, so virtual threads in summary you can say it is going to improve the performance. Earlier we had limitation like concurrent programs, how they can be executed, they were limited by the hardware that we had. we had 4 cores, 4 threads could be executed concurrently. But with virtual threads now, we can spawn any number of virtual threads that is needed. We needed thread pool earlier, right? With the physical threads, platform threads, other name is that platform threads. We needed to pool the threads so that system does not need to create that again and again. With the virtual threads, it is advised not to create the pool of threads, but use them as needed, destroy them when their job is done, create the new one when they are needed. So it is going to give us in the Java ecosystem a lot of flexibility and a lot of optimal hardware utilization around the threads executing the concurrent programs. This also needs a dedicated video, a long video, to understand the virtual threads with the examples that I'll come up definitely in separate channel and separate things, right? So for now, just think this feature is finalized in Java JDK 21. Coming to the next one, what we have, key encapsulation mechanism API. So this is again related to the security mechanism when we have cryptography related things in place, symmetric, asymmetric keys. This feature is related to that one. So if you're using that one, it again needs an example to get the better understanding. So but this feature is there. So let's see the details about this one. What this key encapsulation mechanism is. What it contains 3 functions. A key pair generation function that returns a key pair containing a public key and a private key. A key encapsulation function called by the sender that takes the receiver's public key and an encryption option. It encrypts a secret key and a key encapsulation message called ciphertext. The sender sends the key encapsulation messages to the receiver. A key decapsulation function called by the receiver that takes the receiver's private key and receive private key encapsulation message. It returns the secret key. So it again needs an example, proper example to understand it better. So I will create something separately for this as well. But for now, let's see. This feature is finalized here. So these are the features that are the main one. So let's see. What are the preview features? String templates, foreign function and memory API, unnamed patterns and variables, unnamed classes and instance methods, scoped values, structured concurrency. These are going to be the preview features. Let's see a bit detail about this one. Okay, so again, so the preview features, they are not to be used in production as of now because they are just preview and subject to change. A lot of changes there, so not advised to be used there. So you can see that preview, the links are here, you can read more about it obviously. So I'll only cover so again be focused on the main features. So these are the names that you can see that these are going to be when they are going to help us a lot, like this foreign function, unnamed patterns, unnamed classes and instance main methods. This is interesting. Earlier, to write a hello world program in Java, we needed to know the entire structure, like entire structure of the class, main, static, void, everything, right? So a lot of writing in comparison to other programming languages. Just open a file, write a main function and you get executed. So that functionality has come with this one, with the unnamed classes. So let's see the example how it is there. So this is the right now what we do, right, to print the hello world, right? So you see the problems also with this one. So see from the perspective of the newcomer, which looking at the Java at first time. So this is how they are going to be changed, like class hello world, there is no need of public and sort of thing. Main, void main, there is no need of public, static, there is no need of any argument, just it is going to print the hello world. This is going to be the unnamed one, like void main system.println. So this is again a preview feature. To enable it, we have to if you want to try it, so obviously you have to do the enable preview to run it, right? Java C release 21 and this enable preview, and it will work then. Okay, so this is important features. Another one is scoped values vector. Then we have structured concurrency. Around concurrency, every release they are going to add anything around concurrency or threading, multi-threading. Do read those about it, because they will give you the understanding around the designs and thinkings. They are like lot of important parallel processing, because latency is going to be critical in the latest in nowadays applications that we write. So it is important to go through those. So structured concurrency, I'll also cover this one in a separate video. This is critical features, and going to take care of the problems that we have as of now. So let me go through the examples directly, what it is talking about. So here this handle method is there. So in this handle method we have two function calls. First one, it is going to get the user details, and the second one is going to get the order details. And this user and order details that it is going to, they can work in parallel. So this is how it has been written. As of now we do the programming, right? But let's see, user function has written properly, but order function is not returning properly. But caller does not have a way to know which one is failing or when it is failed. So there is not a proper way for that one. So structured current in the mind it is there, but physically it doesn't exist in the coding style how it is executed. Structured concurrency is going to give that whatever is in mind, it is going to be in the program also. See, this handle, the user find, the user fetch, order, response. So this needs a bit detail. So but you need the you got the gist, right? So it is going to bring that structuring around the concurrent programming when we write such programs. Okay, so let's move to the next features that we have. Incubator, whatever they are deprecating, they are going to deprecate the I think as a programmer it should not worry us or something that they are going to remove it, but they should know it. Deprecating, they are going to deprecate the 32-bit port for Windows 32-bit port. That's it. Details, you can see that in the document. They are going to prepare for disallowing the dynamic loading of agents. Again, details you can get there. Incubating, Vector API is still in the incubation phase. Again, if it passes that incubation phase, as I told, it is going to be in the preview, then it will come as a main feature. So long journey ahead. All other things, just to finalize, always come to this one for the detailed understanding about each and every features that they have. It gives you the core proper understanding about this one, right? So that was all about this one. I got to know about the features. JDK 21, I know it might be boring as it is for me as well, but I can't help. So that's what it is. It is going to help me revise this one, that I created something around this. Okay, so I'll see you in the next one. Take care. Bye bye.